we are going to cover, I don't think we can finish chapter 3 today, but chapter 2, just review really quick that we learned how to summarize, like express the data, and you can choose different graphs like what you guys did, okay, or tables, or like pie chart, histogram, line chart, Pareto, stem and leaf chart. Okay, so we can use that to kind of show our data. And then we also learn, I changed that, but it's not safe. So we learn how to group different data into different groups, like how many groups, how to decide how many groups. So if the sample size is 50, then 2 to the power of 5 is 32. It's not greater than 50. But the next one, 2 to the power of 6 is 64. So we can divide the 32 sample into, the 40 sample into 6 groups. Okay, so the n is the number of observations, like the sample size. And then, so that's how we do that. We use the maximum value minus the minimum value divided by either 5 or 6, so far that's our example. So the quick example here, so to group this data with 40 values. So if we put it in 5 groups, then 2 to the power of 5 is 32. So we have to use 6, we need to separate it into 6 groups, okay? So the smallest number is 2, and the highest is anything bigger than 23. All right, so it's 23 minus 2, 21 divided by 6. So it's like 3 point something, okay? So we can either use 3, maybe, or 4, okay? So I'll use 4. Let me double check. See if it's over 3.5. So 21 divided by 6 is 3.5. Okay, so let's do 4. Okay, so I would do 1 to 5, and then 6 to 10, 11. Is it 4? Yeah, 11 to 15. No, this is actually 5. So it should be 1 to 4. Sorry, because we include 1. 1, 2, 3, 4. Okay, 1 to 4, and then 5 to 8, 9 to 12, 13 to 16, 17 to 20, 21 to 24. Okay, so then we have 6 groups. Yeah, this is what we want. Okay, so 1 to 4, we will have 2, 3, 3, 3, 3, 4, 2, 2. So we have 2, 2, and then 3, 3, and 4. 5 to 8. We have 1, 5. 1, 6, 2, 6, 1, 7, 2, 3, 8, no, 5, 8. 5, 8. Yeah.
I think we have a 0 in there too.
Oh
Yeah.
man, I didn't see the 0. So see, so in theory, if we have Excel, we can rank it first. But if we don't, then we might, I didn't see the 0. So it should be 23 minus 0 divided by 6. That's 4. Okay. So here we should do, oh, it's the same then. 0 to 4. That's good. Yeah. So this is good. This is good. 0, 1, 2, 3. So 3, 4, 5, 6, 7. Yeah. 4. Oh. 15, 11. So I can move the 8 here. And then I can move the 4 here. about 10, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 16, 11, 1, 2, and then 12 to 15, 12, 13, 1, 13. Oh, there's a 12. 12, 2, 13. Any 14? 14? No. So 116, 117, 1, 218. And no,
Oh, there's one.
119,
Yes.
219. 1. I see only 1. Oh, yeah, 2. Man. Okay. 20. 20, I see 1. 21. 1, right?
Yeah.
22. No, 23. So this is not, so we should count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You missed 4. Okay, so 0, 2, 1, 2, 2, 2, 3 might be more. 1, 2, 3, 4, 5. Ah, I missed 2, 3. How many 4s? 1, 5, 2, 1, 2, 1, 1, 5. And then 6, 1, 2, 2, 6, 1, 7. Okay. So 8, 1, 2, 3. Wait, 1, 2, 3, 4, 5. Yeah, I 8. 1, 2, 3, 4, 5, 6, 6, 10.
Missed a 9.
I missed a 9. How many 9 I missed? Oh, 2 9. Okay, now we add up. Now we add up to 40. Yep. Yep. Okay, so that's it. That's how we group the data. Okay, and then previously we calculate how many 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 between 0 and 3, and then we have 1, 2, 3, 4, 5. 5 between 4 and 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. So this is 6, 12, yeah. Okay. So that's, that. So, wait, what? I forgot to. Let me just get it from the here. Okay. So I just go over quiz 2 really quick. So identify the following as either discrete or continuous data. So number of students absent from our statistics class today. A lot. So is it a discrete or continuous data? Discrete, yeah, because we cannot have decimal point, right? And then the number of hours a light bulb burned before going out. So this will be continuous, yes. Because the light bulb wouldn't just go off after 1 full hour, right? And then the number of light bulbs that burned for more than 1,000 hours in a quality control program. Yes, discrete. Number of minutes an airplane flight was late. That's continuous. The number of rate card a dealer had on itself discrete, okay? The number of inches in a person's height, that's continuous. And then number of run. Because we could be, like, I could be 5, 3, 1, 2, 4, 5, 6.
Okay.
Depends on how like precise my,
Oh,
the, you know, because you can like, yeah.
Okay.
Yep. So the following table shows the number of stars the 25 review give Amazon's Kindle. So what's the frequency distribution for this one? Oh, so I have to do this again. I don't know if the owl can see it, but we do this, okay, because this is, so for this one, because they have 5 stars, so each star will be their own category. Unless we can put 1 to 2 in one category, 3 in one, and then 4 and 5 in one. Either way, but let's do 1, 2, 3, 4, 5, okay? So 1, 2, 3, 4, 5, because it's not, you know, it's not a lot of data here. So how many ones? 2. How many 2s? 1. Okay, 1. How many 3s? 3. Okay. 4. 7. Okay. And how many? I assume 7. 5 or 12. 12, yeah, 12. 12. Okay, so when we add it up, it's what? So the first thing we want the frequency distribution. So this is the frequency 21372. Okay, the relative frequency will be, we add it up as 25. Okay, and then when we use 12 divided by 25, what is it? Is it, let me think. Oh my God, 0.48, right? And then 0.28, 0.12, 0.04, 0.08. That's the relative frequency distribution. Cumulative, we add it up. Okay, so the cumulative, this is 0.8. And then the second one, we add this one with this one. So it's 0.12. And then the third one, we add this with this, 0.24. And then let me just add this with this, 0.52, right? This with this, eventually we get 1. So this is the cumulative distribution. And then histogram will be 1, 2, 3, 4. I'm just, this is not very accurate, okay? And then 5. So this is 2. This is 2. This is 1. 1. This is 7. I mean, 3, 7, and 12. Okay, so this is 1, 2, 3, 4, 5. Different star. Oops. Blue star. 4 star. Stars. Yeah. So that's it for this. So this is the descriptive distribution. I mean descriptive. You did it afterwards? No, I didn't grade it yet. I'm just reviewing chapter 2. So for this one, okay, so this one we have, so the good thing about this, I should be like more evil. So if I'm more evil, I would randomly put this here, then you have to sort it. Okay, you have to sort it like what we did here. So, but I was too nice. So I actually put it in different, like from the smallest number to the largest number. Okay, and then we have 30 data, 30 observation. So what's our K? So same as this one, right? 2 to the power of 5, yes. 2 to the power of 5 is greater than 30. That is 32. So the K is 5. So for here, 87.7 is the largest number minus 40 divided by 5. What is this? So it's 9 point, so this is, wait, 47.7. 9.54. Okay, so you can use 9.54 or just you can round it to 10. So let's do 10. Okay, we can do 40 to 39.99, and then 50 to 59.99. Okay, so either way, 40 to 49.99. Okay, so how many is between 40 and 49? 3. So we want the frequency distribution. The first one is 8. Frequency distribution. And then 50, 1, 2, 3, 4. 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then 1, 2, 3, 4, 5, 6, 7. 7 and 2. Does it add up to 30? 9 and yeah, 30. So B is relative frequency distribution. 3 divided by 30.1. 4 divided by 30. 0.13.
Yes.
14 divided by 30. 0.46 or 47.
47.
Yeah. 7.22. No.
23.
23. Okay. And 2 is 0.1117.
0.067. So it would be
Huh?
0.30.
Oh, 0.07. 0.07.
Yeah.
So does it add up to 100? Or we do the third one, rather the cumulative, right? So let's do it. So this is 0.1, and then you add this up, 0.23. Then you add this up, 0.70. Then you add these two up, 0.93. Then the whole thing, 100. And 1. And histogram again. So since this is continuous, so we have to kind of connect them. Okay. 40, 50, 60, 70, 80, and 90. So this one is 3, this is 4, and then 2, and 7, and 2. Okay. So that's it for quiz 2. So now we have to, in chapter 2, we kind of show you how to express, how to summarize the descriptive statistic. So now we need to kind of measure, to calculate the descriptive statistics. So several things. We want to measure the central tendency and how close this is, like this, how close it's going to the center, okay? And then the variability, like how much it range. And then we will use mean, the average, and standard deviation. I'll tell you what it is. And then, like here, if we get the data like this, instead of the raw data, like, the numbers, like 40.0, 52.3, those are raw data. And this is the group data. So if we don't have the original data, all we have is this. What do we do? How do we calculate the average with this? Okay, we can get the estimate of the average. And then, what's the relative position for? How do we calculate relative position? So today, let's kind of talk about the central tendency. So example here is, we will have, like, we can look at the histogram, okay? So this is the height of US adult male. Someone is like less than, probably 60 to 62 inches, is it inches?
Yeah.
Yes, 60 to 62 inches, 62 to 64, 64 to 66, 66, yeah, so on and so forth. So, yeah. So this gives us the distribution, how this look like this. So majority of people are between 68 to 72 inches. So that's about what? 5'8" to 6'2". Yeah, 5'8" to 6'2". 5'8", 68. 68 is 5'8". Yeah, 5'8" to 6'2". So here. Oh, I didn't know majority of people are like 6'2". Interesting. So, so to describe the central tendency, we use 3 stuff. One is average, one is median, and one is mode. So we will talk about it later. So the mean is the average, right? So to calculate the mean, we basically add up everything divided by how many sample we have. Okay, so for example here, these are 5 randomly selected families, their average income. That's 82.2, 118.9, 76.2, 107.7, 61.5. So we just add it up, divided by 5, equal to 90.3. So the average household and family income is $90,300 per year. Okay. Here's something I want to, you might not remember, but it's okay, but I'll keep reminding you, but try to, know the difference. So when we calculate statistics, like in this case, we have the sample because we only select 5 selected, examples. So this is the sample. And when in statistics, we use different sign for different data. So for sample, we use X bar. So it's written like this, X bar, X bar. So when I like say, or sometimes when I write on the board, I might do this, I might do this, and 87.2 plus 108.9 plus this, okay, divided by 5. So 90.3. So I might do this. So this, you know, this is sample. Okay, and for sample, we also use smaller n as the sample size, smaller letter n, and for population, we use the capital N. And here, instead of X bar, we use this mu. It's called mu. Not you, mu. I don't know if it's Greek or Roman. Greek? Okay, thank you. We understand Greek. So this is mu, okay? Mu. Wait, let me think. Mu. Yeah, my cat name is Mu. Yeah, my daughter named him Mu. Not because of this. Really, Mu? No, that's meow meow. Oh, and the sign is mu. I have that. I have mu too. Yeah, so this is mu, okay, population. And then this is the capital letter N. So that's the difference. So this is the average. So you see here, we change when we talk about population, we change the smaller n to the capital N and then X bar to mu. Okay, so hey, at least you guys now easy to remember. So weighted mean is like when you calculate your GPA, you take a class that's 4 credit, you will times 4 with your, whatever like ABCD you get. And then if it's 3 credit times 3, when it's 1 credit times 1. So for weighted mean, it depends on how much one data weighted in the whole set of data. So I'll give you one example. Okay, so like, let's say Tom, I use Tom. Tom is my ex-husband's name. So you can see I'm not very creative. So so this is like old example I created when I was married. So so the exam he got 94. Okay, the exam weighted 50%. And then we have project that's weighted 35%. Homework 15%. So totally the weight should be equal to 100%. Okay? Okay? So to calculate the weighted average, how do we do that? It should be, I think you guys should know. Do you guys know how to calculate that? No? Okay, I'll show you. So the weighted average will be 94 times 50% plus 92 times 35% plus 100 times 15%. That's it. Then that's it. The answer is here. So the final grade is 94.2. It's an A. Yeah. Okay. So remember, this has to be, this need to add up to 100%. Okay, if it's not 100%, that means something must be off. Okay. So how about, okay. These two, student 1 and student 2, like they have 3 tests. What's the average for student 1? What's the average? So they have both students take 3 tests, right? So this is their score for 3 tests. That's 1, 2, 3. What's the average for student 1? How do you calculate that? 80. Yeah, each one is equal, like 33%, 1/3 the grade. So we just add 60 plus 80 plus 100 divided by 3. Okay, so it's 80, right? This one. And this one, what's the average? 82, right? 80. So this tells us when we use average, this is what happens. Like both students, the average is 80. But if I need to send one of the students for a competition, which one should I send?
Or no, send student 2.
Why?
They have better grades. Even though they still have the same average.
They have more consistency in their grades.
Yeah.
Consistency, yes. So it's probably safer to say, I can know for sure this second student probably will get 80. Okay, but if I'm risk taker, or if I'm gambling, yeah, but it could be worse, right? So it depends. It depends. But let's just show us that when we just look at the average, it doesn't really explain a lot of stuff. Okay, so sometimes that's the pitfall of the average, because they all have the same average, but this one is more consistent, and this one has more potential to succeed and potential to fail, both. Okay, so this is, that. So that's why when we have an average, we might be, the average might be affected by the outlier. This is not a good data. I try to create something more like extreme, but I got this rotted with all the meetings and I forgot. So wait, oh yeah. Okay, so this one, you see that if we don't look at the outliers, oops. So if we don't look at the outliers, the 80, the average here is 70 inches, right? But if we calculate the outliers, then the average is like 72.5, which is a little bit higher than what we saw from the previous data. So if we have a smaller sample size, it would be influenced by like outliers more. So that's why sometimes when we want to have a bigger sample size to look at the data, okay? So it will give us more accurate estimate. So I'm trying to find finally my Pokemon. So let me see. Oh, internet is so slow. Is it called Mew? MU?
MW.
MEW? Oh, I do have, yeah, see? I have Mew and Mewtwo. 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 See? Mewtwo. I don't even remember how I got it. So, medium. So when we have like outliers, sometimes we can look at median, okay? Because median is where the observation, like right in the middle, that's called median. So we don't really need to like calculate how like far away the outlier here is or the outlier here. But whatever in the middle, you know, it's like the closest to maybe the center data. Okay, so that means we just find whatever in the middle. Half of the data would be smaller than this number, half would be greater than this number. But what if we have an even number? Okay, so if we use a previous example, so this one, if we have to put it in the from lowest to highest, so 69, 70, 71, 80. So the median is 70 and 71, right? Because it's an even number. There's no like number in the middle. So it's 70 and 71. So the median will be the average of 70 and 71. So it's 70.5. So 70.5 is closer to the real like center of the data than 72.5. So this is the median. So another example here, okay? So we have 86, 95, 74, 83, 92, 70, 88, 81, 91, height of the US adult male. And then we will put this number in the ascending order from the smallest number to largest. So this is the new order. And then we can calculate how many. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So it means if we get this number 9, then it's the, what is it? The I is where is the median, okay? It's 0.5 times 9. So that's 4.5. And we round it. 4.5 is 5. And we round 4.5, that's 5. So that's 1, 2, 3, 4, 5. This one is the median. So if you see here, this number, below this number, we have 4 numbers, and then above we have 4. So this is the median. Okay. So when the number is odd, that's that's the number we have. But if the number is even, so let's say if we don't have the 95, we only have these 8 numbers, then the median is here. It will be the average of 83 and 86, which is 84.5. Okay? Does it make sense? Yeah. So here, so if we have an even number now, okay, we add 20 in front of this. So now, between this and this, we have 5. So since it's a even number, 1, 2, 3, 4, 5, 5 and 6, these are our median. Okay. So the median will be 83 plus 86 divided by 2, which is 84.5. And the outliers don't actually affect the median. But if you calculate both like this example and the previous example, the average, this outlier will affect the average a lot. Okay, but the median is still similar. So. And the mode is the numbers that show up the most often, has the highest frequency. So this example 1, 2, 2, 3, 5. So the mode is 2, right? It's the most often number. What about median? What's the median? In this case, 1, 2, 2, 3, 5. Very good. How about mean? testing your calculation.
Like,
No, there's nothing over 6. It wouldn't be 6.5 at all. Because nothing greater than 6. The average will be,
all of the error.
divided by 5, because there are 5 numbers. Yeah. Okay, so it's what, 2.61, okay? That's the average. So if this is the data, then in this case, nothing is small. Then they only appear once. In this one, 1, 2, 3, 4, 5, no data. So for a data set, we can normally get an average number, the mean. We can get the median, in this case is 3, but for mode, not necessarily. Okay, when the data is big enough, maybe, but not necessarily. Okay, so this is the high value. Okay. And because I have this open in the other computer, that's fine. So the frequency distribution, we already kind of talked about it, right? Like from the previous chapter. And so from the frequency distribution, usually like when we have the mean as the same as the median, it will look like this, like good, like perfect shape of the bell, like a, what do you call it? A symmetric bell shape. Okay, so the mean and median are here, and usually, see, this is where the mode is because it has the highest frequency. Okay, so that's a bell shape distribution. But if we have the median greater than the mean, okay, because we have like a lot of data are like here, like we have a very how should I put it? We have a number that's, they have very low value in the end, but a majority of people are like here. So this is called left skew or skew to the left. Okay, so it's like, you know, like this. Then that means the average will be somewhere here, and then the median will be here, because a majority of the data is here on the greater side, on the right hand side. Okay, so this is a skew to the left skew. Median is greater than mean. On the other hand, if we have something that's skewed to the right, okay, so this is usually like our test score. Okay, we have more people scored 80, 90, 100, or you know, ABC, very few to the lower score. Okay, so the median is here, but these people, they will make the median, the mean a little bit lower. So, but the majority of people are here, so the median is here. But this one is more like income. So majority of people, you know, make this much, and there are some like really rich guys that make a lot of money. So they kind of make the median, I mean the average higher than majority of people. So the median is smaller than the mean. So that's skew to the right skew. Okay, so those are the two different type of distribution. So when we use Excel, we can easily put in like average. Okay, put in the function as average, and then we can put in median, and then mode to get, get into calculate. And then we can also use data, using data analysis and then descriptive statistics. And then we can select the range and put the output range where, we're going to show the table. And then they will have a summary statistics. So it looks like this. Okay, so when we do descriptive statistics, we could say we can select, this is the input, so these are the data we want to include. So those are the input. We get this. So here we put in we select this area where we have the raw data. Okay, and then the output, we can put it like here or the area here. And then this is the descriptive statistics. So they will tell you the mean, they will tell you median and mode. What is the standard error, standard deviation, all this calculation. The kurtosis, skewness is like the how tall this is, or how how skewed the data is. You don't have to know this for now. Yeah. Just need to know the term. So about mean, median, and mode. Mean is easy to use because we will have sample and we use sample to kind of predict the population, and we can calculate the weighted average and weighted mean. And median is like when we have outliers, the mean number might be affected. So in that case, we can kind of look at the median. It will tell us, what's the median. There's a median income. So maybe the average income, maybe it's 100K, but the median might be 60K. So it means like 50% of people make less than 60K, 50% of people make more than 60K. So that's a median. So it's probably closer to majority of people are making. But the average, the mean might be 80K because we have people making billions of dollars, right? So they make the average higher. So that's when we have outliers, median might be a better indicator. And the mode is like when we have a category data, we can kind of see, where do majority of the population lay on, like where are they? Yeah. So those are the three basic things that we use for the measurement of the descriptive statistics. So this is data from an airline company, and we have different numbers of no-show. Okay, so like so they collect data from maybe about 100 different flights. So out of this flight, let me see what is the total. 8, so 100 to 120. So out of 120 flights, 37 have 0 no-show. Okay, 37 out of 120. Everybody that booked the ticket show up. But 31 out of 120, 1 no-show. 1 customer didn't show up. And then 2 no-shows in 20 flights. 3 no-shows in 16 flights. 4 no-shows in 12 flights. Only 5 no-shows in 4 flights. Okay, so this is the no-show data. So in this case, okay, what is our mode? Very good, 0, right? 0 has the most frequency. What is the median? So the total is 120, right? So the median will be 60 and 61. right? Where are they? Where's 60 and 61? Here. Because here has the data from 38 to 68. So 60 and 61 are both 59 and 60. Wait. Oh, 60 and 61. 60 and 61 are both here. So the medium is one no-show. Okay. Average, we'll talk about how to calculate group average later on. So this one you don't have to worry about it. But we can, well, we can still calculate it. So we can do 37 times 0, 31 times 1, 20 times 2, 16 times 3, 12 times 4, 4 times 5 divided by 120, because we have totally 120. That will be the average no-show. Okay, are you calculating it?
Yeah.
Oh, good. So what is it? It's probably, I'm guessing 1 point something. See if I'm right. Oh,
1.56.
yeah, 1.56. See? Because like a lot of this has 0 no show. So they will make the average that. So, but actually that. So this one shows the minutes of the US housewife spent in chores at the weekend or on the weekend. What is the median and mode for this data? Oh, this is, so did you guys do it? You have to put it in the order, ascending order first. What is it? Should I do it? So let's do it. So the smallest number is 26, right? And then 28, 31, 39, 43, 45, 245, 57. Did I miss anything? And then 62. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the median will be what? 5 and 6, right? The average of 5 and 6 here. So what is it? $44. What about mode? Very good. Yeah, so that's it. Very simple, right? Yeah. How about this one? This one you have to calculate the what is it? The average as well. Okay, and then I don't know if you remember, but you know, the left skew is one is mean greater than median, one is median greater than mean. So let's see. Let you do it first. What's the average? Yes, good, good. What is the median? So median is greater than the mean. What is it? Left skew?
The median greater than me, right?
Yeah,
That's-
yeah, median greater than mean. I have to go back to see
that's
this.
what-
Yeah, left skew. So that's it, that's the left skew, okay? And then to look at variability, how volatile the data is. We can look at range, you know, how big the range is, variance, and standard deviation, okay? So range is basically the largest number minus the smallest number. It's very easy to find out, right? But sometimes it doesn't really represent, you know, the data, okay? So for sample, again, for sample, we use the variance. For sample variance, we use the small letter s squared, it's a variance. Standard deviation is sample letter, means small letter s, okay? So because standard deviation is the square root of variance, so it both has to be positive number. There's no way they are negative, okay? So to calculate the variance, we use the data minus the sample average x bar, and then take the square, and then add up all the square. After we add it up, divided by n minus 1. Like 1 minus the total number minus, you know, 1. Okay, and then the standard deviation is just the square root of that. So just like let's try to calculate this one. So the first one, the formula approach. We should calculate x bar first. So we would do x bar equal to 35 plus 10 plus 50 plus 20 plus 60. That's 90, 140, 175 divided by 5. 35. Right? Okay. So the variance. Let me do this one. So that's the xi is 35, 10, 50, 20, 60. Okay, so let's go back. Let me show you, because I want you guys to get used to the symbol. Okay, it's already here. So the formula approach, okay, we use xi. So this is xi. This is xi minus x bar, that's 35. Okay, so minus 35. So we would this spot. So 35 minus 35, 0, 10 minus 35, negative 25, and then 15, and then next 25, and 25, right? And then we need to take the square, xi minus x bar square. This is 625, 225, 225, and 625. So we add it up because we need to do the sum, right? What is it? So this is like 850, 1700. Right? 1700 divided by, then we have to divide it by 4, yeah. So what is S2? Divided by 4. 425? And what is the square root of 425? 21?
5 times the square root of 17.
Yeah, square root. Square root of 425. Is it 21 point something?
Square root of 17. Put in the decimal.
Yeah, that's. Sorry, so it's 20 point something. By square root, come on. 425 square root, 20.62, okay? So that's the standard deviation. Okay, so if we calculate like using formula, we are supposed to do like 35 minus this to the square plus this to the square, this to the square, this to the square, this to the square, divided by 4, and then square root. Okay, so the tabular method is similar, actually similar to what we did. So this is x bar, and this is xi minus x bar, and the square. Okay, variance would be 425, and then the square root of variance is 20.62. Okay. So when we have population, the only difference is the sample size. Okay, when we use samples, smaller sample, here we use n-1, the denominator we use n-1. When you use population, when you see the question or the data saying that it's a population, or they give you calculator n, then you just use n. And then standard deviation for sample is S. For population, this is what? Sigma? Is sigma or alpha? Alpha is this. Sigma.
Yeah.
Sigma. So this is sigma, okay? For population, sigma. Alpha, the alpha and beta, okay. So this is sigma. Okay. So this one. So this one is another formula, similar as this one, okay, similar, but they kind of simplify some of the data. So instead of using each one of the xi minus the average, we just need to calculate the xi to the square and add it up. Okay, so that means, yeah, so that means, yeah, we just square the data and then add up the sum of the square and then minus the sum of the total data square divided by n, and then divide the whole thing divided by the sample size. Okay, so let's try to simplify that so that we will have the similar result. And then after we calculate the standard deviation, S or the sigma, and then S divided by the X bar. So when we calculate the standard deviation, we know how dispersed our data is. When the standard deviation is bigger, that means it's further from the average, okay? Because when you go back to the formula, you can see that we show this. So we use the difference between our raw data with the average. And then we squared it because we don't want, if we just add this up, it will be 0, right? Because this is average. So we want to take the negative number and also positive number, we want to square it to see the distance from each data to the average. So this is actually the total distance. And then we divided the distance by the sample size. Okay, so that's why we have this as a variance. And then the square will be the standard deviation. So in theory, that's how far the raw data to the average. Okay. So when we use that, sometimes if when we have a data, the average, let me put it this way. So if we compare a data like the average of the income in our class to the average of your grade in the test 1, okay? So one average, let's say, like you might make, let's say weekly income. So somebody might make $1,000, somebody make like 2,000, maybe 3,000, you know, like that. So the average will be, let's say $1,000 a week. So when we compare like this, is this data more dispersed than like your grade, your test score for test 1? Okay, so if both standard deviation is 2, it doesn't mean they are the same dispersed because this average is 1,000 and the test score we know the most is 100, right? So out of 100 and the average, let's say 80. So in the class, the average is 80 points. And people are making in average $1,000. Both standard deviation is 2. So that means this 2 standard deviation means much smaller than these 2. So that's why we use the coefficient of variance, because we want to compare the relative size of the standard deviation. So we see this is the standard deviation divided by the average. So for the income, our coefficient of variance is 2 divided by 1,000 times 100%. So that's what? 2 divided by 1,000. 0.2%. 0.2%. But for the score standard deviation, if the coefficient of the variance will be 2 divided by 80. That's 1/40 times 100%. 2.5%. So it'll be 2.5% versus 0.2%. So that means in other data, they are more centralized. They are much less dispersed than the score data. Does it make sense? Okay, so you have to compare with the average of the data because you know the average might be different. And if the standard deviation is the same, then whatever have bigger average means that their standard deviation is actually smaller. Okay, their variance is smaller. So that's the coefficient of variance, CV. For one example, one data set, they have average of 55.62. The standard deviation is 5.1. So, and then the second data average is 24.86. Standard deviation is 3.6. So from here, if we look at standard deviation Usually the bigger the standard deviation is, the more dispersed the data is, right? But here, the average 55.62. So if we look at the coefficient of variance, it will be what? About 10. The coefficient of variance is about 10. Okay, maybe a little, maybe not. But for this one, 3.6 divided by 24.82, the coefficient of the variance might be like 12. You calculate it? So.
Yeah, 14.
So 9.2 versus 14.5%. So the first one is actually much more consistent than the second one. Okay, so we have to look at the average, like the sample, the average, the mean. So do you want to do this one? I'll let you guys do this one. Standard deviation, variance, and coefficient variance, coefficient of variance. Can do it, please. Did you have the number? No, not now. I said if you write this down.
No, I didn't.
I'm going to cheat. I'm going to use Excel. Two, 40. We have the calculation. Oh,
I get.
anybody want to volunteer to do this here? Extra bonus point. Bonus points. Here. Anybody? 2 bonus point opportunity. You don't have to be right. Just need to come here. 1 here, 1 here. Anybody? No? 10 points. Bonus point. Hmm? Yes.
That's.
Did he? Okay, wait. Till he. What's your answer
I got 7.036.
for standard deviation? Okay, what is the variance? That would be 40, 50 something, right? Or 53? 0.36, and then square root. And then coefficient variance.
Yeah, that one.
So let me. So this is the variance. Oh, yeah, and this is the standard deviation.
Which
Right,
one? Wait, which one to the?
this is the standard deviation,
Okay,
this is the square root. Square root, and this is the. Not mu, S bar, X bar,
okay,
X bar.
fair enough, yeah, I got that.
So the coefficient variance is the standard deviation divided by X bar. Right,
Okay.
and then percentage.
I must have gotten a higher number for the SD because I was running off, I got 6 3s at the end of mine, so. Like 0.63 for my. The X1 minus X bar squared.
So, yes, oh, okay, because you run it up,
Yeah, so
Yeah.
it's like, I ended up, my
Yeah,
square was
but-
like
but-
49 something.
okay,
But
yeah,
I still
that's
got
okay.
over 7 for the standard though.
Yeah, that's fine. So it's like close,
Yeah.
yeah. So coefficient variance is 22%.
Okay. And
Yeah.
So
So-
it's just the X bar divided by the standard, the SD.
The S divided by X bar,
Okay, so that's
Yeah.
SD divided by S.
yeah. So from Excel, like in the future, if you have a quiz, you don't want to do this calculation, you can go to Excel and then you can just type in average, right? And then select the area. And then same as the, this is the variance for sample. So when you type in variance, you will see that variance P. So they will be based on the population, okay? But in our case, this is the sample. So we select this. Okay, the only difference is, remember, population are divided by N. For sample divided by N minus 1. So for this one, the number will be smaller. So let me show you this. So if I use this and I select the same thing. Now they will divide it by N, not N minus 1. So this number will be smaller. See that? Oh, maybe that's why you got 45. Did you divide it by
I divide by 7. Divide by 7.
7? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So if you divide by 7, it's this one. Yeah. So this is the only difference. Same as the standard deviation. If you type in ST, okay, so they have this one based on the population, and this one based on the sample. Okay, so that's it. So yeah. So this is the coefficient efficiency. And then the next thing is Z value. Okay, so since our data, like we mentioned, we have different sample size, we have the different standard deviation with different average. Okay, so how do we calculate like how do we use this data and then try to make estimation? So we have to like standardize the data with our standard deviation. So and then the statistician, they actually come up with this standard table, standard normal distribution. They will calculate the Z value for us. Okay, so the Z value is a standardized normal distribution number. When we calculate how far our data is to the average in terms of how many standard deviation. Does it make sense? Okay, So, for example, well, I'll show you the chart. Show you, let's see if I have. So for example, here, okay, so here, if we have score for exam, average is 80, okay, and then the standard deviation is 5. So for this one, so this is the average, 80 plus minus 1 standard deviation. So this area, okay. So when we have plus minus 1 standard deviation, that means this is one z value, this is one z value, okay? And then we assume this is normal standard deviation. So plus minus 1 z value, this is 68%. So there are 68% of chance the data will be within plus minus 1 standard deviation. Okay, so when we have the data like this, we have to convert it to z value. So how do we convert that? Because this is based on how many standard deviation. So we will convert it by using the x is like any x number we want, minus the average x bar divided by standard deviation. So that's the z value. Okay, for population, again, we just replace the x bar with mu divided by sigma. Okay, so this is the same S and sigma. So when we calculate that, we can calculate the z, where this is when it's like when we use a normal distribution. Okay, so to get z value from Excel, we can let me see. So we can do maybe standardized. Okay. Sure, I'm not sure. Standardized. Okay, so click standardized. It will tell you the x. Okay. So x is like given, you have to assign an x. Okay, so let's do 35. And remember the mean is 33.75. Right, so what I can do is I can just select this. And then I can select the standard deviation. And then they will calculate the z value for me. But we can also calculate it on our own. Okay, we can use the data. I mean the formula like I told you guys. So x minus x bar. So in this case, the x I use is 35. So all we need to do is use 35 minus 33.75 divided by standard deviation point something. Okay, so we get the z value 0.17113. Okay, so that's how we get the z value, and then we need to look at the table to get the probability. But we can also for this one I'm just going to show you how to calculate it. So the z-score example is, so how far is 670 calories from the mean? So the mean is 776.3. So we use 670 minus 667.3 divided by standard deviation. So it's negative 0.276. So if we draw this would be 776.3. This would be the average, and then this would be 670. Okay, but if we move it to the standard deviation, the standard distribution, normal distribution table, this will be 0. This is z equal to 0, and then this will be z equal to negative 0.276. And then we can use the table that I'll show you later to know what is the probability here.
I have the plus or minus.
Yes. So I'll show you that later, okay? So this is how we convert that to z-score. But before we actually go on to that, so that shows that this is a symmetric bell-shaped pattern, normal distribution, and usually plus minus 1 standard deviation, we have about 68% of our data. Okay, plus minus 2 standard deviation, we have 95%. And then plus minus 3 standard deviation of 99.7%. Okay, so if we want to know, like we know the average is 80, and then we know the standard deviation is 5. So what, like, but like, how do we know, like, the 95% of students, the score will be arranged between what? Then it will be 95% will be plus minus 2 standard deviation. So it will be plus minus 10. So we will know 95% of students, their score will be between 70 to 90. Yeah. So it will between 70 to 90 because it'll be 80 plus minus 2 times the standard deviation, which is 5, which is plus minus 10. Okay. So that's that. And then we have, sorry? Yes. So, yeah, it's under,
Yeah.
under content, slides, and then it's here. Okay, yeah. And then I also like the recording is here.
Yeah, that's the YouTube one, is that?
Israel. Yeah. So this one, you know, in the this data, they have different pattern. That's we call Chebyshev formula. So he used like a very rough formula to estimate the percentage of the value that would be between certain standard deviation. Okay, so for that we can use the z. If the z equal to 2, means it's plus minus 2 standard deviation. Okay, right? 2 is plus or minus 2 standard deviation. So he used that to be 1 minus 1 over 4, 2 to the square, 2 square is 4. So 1 minus 25% times 100. That's 75% of chance this will be within the mean. Okay, but in reality it's actually 95%. And then 3 will be 89%, but in reality is 99.7%. So if it's not the normal distribution, we will use this Chebyshev formula to kind of estimate, okay, around how many percent is within 2 standard deviation, 3 standard deviation, okay? Yeah. But in the normal distribution, we know it's 68, 95, 99.7%. So let's try to let's see. So let's use the Chebyshev's rule. So let's say 75% chance to verify whether or not these are within 2 standard deviation. Okay, it is 75% of chance. So have to what's the mean? We have to calculate the mean and then the standard deviation. So let's see. I'm not going to do that. Yeah. So how about this one? So I'll skip it today. Okay. Next, maybe. Well. Oh, let's do this one. Okay. So what's the range that there's 75% of chance the employees bonus is within that range. Okay, so how do we do this? So 75% of chance, we go back here, is the Z is equal to 2, right? So 1 minus 1 over 4, so that's 75% of chance. So it'll be 1,920 plus minus 320. Okay? I'm writing it, where's my, here. So it's here, 1920 plus minus 160 times 2. So 320. So it will be 1,600 to 2240. So 75% of the chance the employee's bonus will be within, or I should say 75% of the employee, their bonus will be within 1,600 to 2240. Okay,
That's it. That's simple.
yes.
That's that question.
Yes, so this is just because it's not, the distribution is not bear shape, so we use the estimate. Oh, let me erase it, so.
Yeah, she got that simple ball.
So under the, if it's not bear shape, it's not normal distribution, we use 1 minus this rule. Okay, so this is Z. So to get 75%, this is 2. Right? So Z equal to 2. So that means plus minus 2 standard deviation. So Z is 2. When Z is 2, this is 0, minus 1, minus 2, 1 and 2. So when Z is 2, is here. So plus minus 2 standard deviation. And then in this case, the standard deviation is 160 times 2, 320. So it would be 1,920 plus 109,020 plus minus 2 times 160. Plus minus 320. So it'd be 1,600 to 2240. This, you can take pictures.
And then the three, you just spread it out more along that line. Right?
Yes. So if I ask you, what about 89%? Wait. 1 divided by 9. Yeah, 89%. What about, I want to know, at this, what range would include 89% of the employee? 89%.
Z equal 3.
Yes. So 89% is Z will be equal to 3. So this is 75%. And then 3. I wish I have read, but so 3 will be here. So this whole area will be 89%. Okay, so you guys, do you want to try? So it will be 1920 plus minus 160 times 3. That's 480, right? So 1920 minus 480. 42, 480, 2,800. I don't know if I calculated right, just check. Oh, no, I was wrong. 2,400. Or a,
Yeah, that's right.
yeah,
that's right.
2,400. Okay, so when the range is bigger, this range should have at least 89% of the employee. Okay? Does it make sense? Like better sense?
Yeah.
Okay. Do you want to continue or let's take a break? Break?
Yeah, let's go after the break.
Huh? Go home. When I say break, like we go home. So we have the group data. We can talk about next time. I think we only have group data. So basically we find the middle number. Okay, like between 20 to 30, we use 25 times 20. And then 35 times 41. And then 45 times 19. Okay. So that's how we calculate the average. And then divided by the sample size, which is 100. Okay, like here. So here, oops, yeah. Okay. So 100 is sample. So we have to, the average we divided by 100, but standard deviation variance we divided by 99. Same as this one. So this one we use 3.1 for calculating GPA. Okay, we use whatever in the middle.
Okay.
Yeah, when we have a group number. So I will finish this next time. Okay. I think it's, yeah, it's a lot. Yeah, so we only have 2 more left. But because it's a lot of calculation, like it's not difficult, it's just annoying. Time consuming to do the calculation. Okay, so any questions? So next time we are going to do this, and then I'll give you quiz 3, and then you will have the take-home exam. But I encourage you guys to kind of, the exam is already on D2L. So I encourage you guys to print it out and try to see if you can do it. And if you have any questions, just let me know, or we'll come and bring it here to discuss. Okay? Well, it's mostly, okay, so, yeah. So like, so like this one, you will have to use the group data, I think, yeah, group data. So for this one. Okay. Oh, it's actually easy, I think. So. Any questions?
So that 2 weeks,
Okay, everything is due by the end of
May.
May. But you want to, like, if you can, you know, try to do it as soon as possible so I can grade it. But like I said, everything is due by the end of May, so you can always resubmit
Oh, okay.
to get better grade.
Oh.
But
So it's
test, you guys have to, the reason for that is the test is not easy.
Hmm.
Okay,
Okay.
so I want you guys to get every score on the quiz and try to learn how to do the test.
Okay.
Okay, but not everybody can get 100% for a test.
Gotcha.
But quiz, I hope you can get 100%. Okay, yeah,
Have a good one.
you too.
That's it.